And welcome back. We're going to continue on with functions with something known as pass by reference. What we've been doing so far is we've had void functions that don't return anything. We've had functions that return a value of any type that we've used, ints, doubles, whatever. So we've been able to use functions to handle one activity at a time and to get a value back if we needed it. So Boolean was a common one that we showed just last time, how you can use a function to check on something and get a value that comes back. Well, what happens if we want to allow the function to actually modify something that's down here in main? So let's say, for example, we have an integer value number like that. So let's say we want to have a function that allows us to increment number or multiply it or divide it or do something to it. So we'll ask the user to give me something. There we go, and we will get something. And now let's say we want to have a function that's going to be, I don't know, multiply it times 3. So we're not going to return anything. Well, let's do it the first way we've been doing things. So if we wanted to triple a number, we would actually have to pass in the number we want to triple. And that's our prototype. And let's write that function. And if we called that, of course, there we go. Just to show that it actually works. Enter a number, 10, 30. So this is the way we've been doing it. This is the standard way of handling one thing at a time. Pass something in, let it do its thing, and make it return whatever it is that you want it to have give you back. Now, this is not a bad way of doing it, but there's an alternative way that allows us to make things a little bit easier, a little bit less creation of variables, and more of a way of referencing things back in here without having to do this kind of thing, without having to have things being assigned to it. So what we have is this concept called pass by reference. Pass by reference allows you to pass a variable not as a copy to the function, but as a reference to the original value's location in memory. This is done by the addition of an ampersand sign in the parameter list. So this says pass a reference to a value of type int. We need to put that ampersand sign also down here. Spacing doesn't matter which way you put it. I just stick it in the middle because it allows me to say a number is a reference value of type integer. And if I do it this way, what's going to happen is I don't need to return this anymore because I'm only dealing with one value. I can turn this into a void function. So the return type of this function is now void, and I can just do the math. There you go, a number times equals 3. So what's going to happen when this is called is this thing right here doesn't need an assignment. It's passing in number as a memory location, basically as a pointer or an alias to this location. So what's going to happen is it's going to say, hey, here's the number's location passed down to here. Triple will say, oh, okay, I know now where to put this if I change it. So when I do the math, this actually comes all the way back up into numbers memory location and changes the value that's stored there. We'll get the same result if we run this. We get the same output, but there's no return on this. It's handling this thing as a pass by reference. This is a very useful thing to do. But here's the catch. When you pass by reference, you are giving this function and any other function that you pass by reference into, total control of what you have. So that means things can change up here because of calls to functions down here, and you have to really understand what's going on to make sure you can get this working correctly, because debugging can be hard to track down because you don't know exactly where some of the changes and the errors might possibly occur. I personally don't use it when I only have one. I like return types. They just seem to work cleaner in my head. But if you actually have to get two values back, let's say I'm going to write a function that says, oh, get two. So I'm going to get two numbers of type integer. And if I pass by reference, that gives me a place to put two values right here. So I can actually write this thing in, copy, paste. And now I can do number 1 and number 2. And inside this little function, I can now do the stuff that I was doing before, which is this, getting numbers. Just doing some copy pasta. So now what I've got is I've got num1 and num2. This function will actually go out and get me two numbers. So if I wanted to write a more complex piece of code just for conceptual thoughts, is I could have this get numbers, pass this off to a validation function to validate the number, and then what comes back to me here is the actual values that I need. So my get2, I'll rechange this a little bit. I'll say get2, I'll pass in number and number 2, which I haven't created yet, so I gotta create that. And we'll just play a little bit with the code. And you can see C-line is actually telling you that these are reference parameters. They're giving you clues that these things are actually coming in as reference. So now what I have a function that says get2. It'll get two values and store them right back into here. The temporary value set that's down here doesn't really exist because it literally has a direct pipe right back into these two memory locations because I passed by reference, which this ampersand sign actually has a meaning that says address of. So you can think this is saying pass me the address of an integer. So when you see the actual function, this is the address of a number as opposed to of actual value that a number contains. And that gives you the values that we want, the memory address that we want to put values in when we get here. So if we run this, and there you can see it works just fine. Now you have to be careful, especially when you start coding more complicated things. Only pass by reference something you want a function to change. You anticipate them at least being able to change it, and you understand that they're responsible for making sure that whatever goes in here is correct. Pass anything that you want a function to use, like a multiplier or whatever, pass that by value. So just to change, let's change triple into multiply, and we'll pass two things in. We'll pass in a multiplier and the value to change. So I can come down here into triple. There we go. So now triple needs a number. We'll do 3, except it's not triple, it's not mult. And do 4, just for fun. So you can see I now have this multiplying function that changes triple, that I pass in this value here, the multiplying value, as an actual pass by copy as opposed to pass by reference. So pass by value is what goes in here. I don't want you to change it. I don't expect for you to change it, even though they're both constants here, and we should write constant variables for that. I can do this and have this thing work just fine, except for when something doesn't work. Oh, it's, I don't know. That's odd. Oh, I have something going on wrong. Mult, oh, mult. Fix the whole thing. There we go. So I can give it the number, and now I get 3 and 4 times those things. So you can see I've used pass by value and pass by reference because I want you to change this. I don't want you to change this. You can. It just doesn't have any impact back up in here, mainly because there's nowhere for it to go. So that's a quick overview of what goes on with pass by reference and some of the concepts of what to look out for when using it. Hope you're having a great day.